Okay, let's start. So today I'm going to complete linear motion part. We have to do special questions and special past paper questions. Okay, take your tutorial linear motion 1. Go to 2006 past paper. 2006 past paper. Read it and start. 2006 past paper. Past paper. Okay, 2006 past paper. There's special thing there. So there's special thing. It says that just catch. Better put star mark and just catch underline. That is very important term. Huh? Just catch. Okay, first sketch the graph. Start, do alone. Okay, here a man on straight road sees a bus. Man on a straight road sees a bus move with constant acceleration from rest. Okay, so here the bus ahead him. He runs with uniform velocity u, he acceleration f. Then man gonna catch the bus in t second, capital T seconds. So here the question. Here time, velocity, given meters per second, here in seconds, here man. Same time they start, bus and the man start, same time. Then here accelerate, here the bus, alpha. Here when you consider d distance, that is given by the displacement difference between bus and the man. Here there is special word that means just catch. That just catch position happen when velocity same. When velocity same, just catch position happen. Here at here. That is very important. Here just catch position. So here displacement of the bus given by this shaded this region. Then displacement of the man given by full region. Then here this part that represent d, no? Displacement gap. Therefore now t given, u given, then tan alpha acceleration of the bus. Bus acceleration tan alpha, then u divide by t, very simple now. U divide by t. Then initial distance of the man from the bus stop, that displacement given by here this area, say O, A, B. OA B area is D. Half into U into T. Half into U into T. That's it. Very simple question, but that term very important. If you can't identify that one, you can't do this one. You have to identify that just catch position. Just catch means velocity same position. Velocity same position. Then you go to 2008 Taylor question. 2008 Taylor question. Start. Continue. Better to mark that question, na? 2006 question. That word very important. Just catch, just touch. So at that point, velocities are same. Velocities are same. Two 2008 question. A train normally runs in straight track with uniform velocity v. Usually it travels with velocity v. Due to a repair ahead in the track, it slows down the velocity to u. At a uniform retardation over distance simple d. Next train moves with uniform velocity u over distance 2d under repair. Then moves with uniform acceleration over distance 3d kilometers. Regain the velocity v. Then that motion change happen, retardation, uniform velocity, acceleration. No? Usually it moves with velocity v. Now due to that, there will be time gap. Due to that, there will be time gap. Here D, 2D, 3D. Then first we need to find time, thereafter we can find time gap. Here velocity u, no need to worry about retardation and acceleration. So without that we can find. Here this shaded area D, let's take this time t1, let's take this time t2, let's take this time t3. Therefore, here D equal half into t1 into u plus v. Therefore, t1 equal 2d over u plus v. 2d over u plus v, first relation. Then here second 2d equal u into t2. Then t2 equal 2d divided by u. Here this area. Then here this area 3d. Half into t3 into u plus v. U plus v. Then here t3 equal 6d over u plus v. Now we have 3 time gap, t1, t2, t3. So usually it travels 6d distance with uniform velocity v, no? Then general time, let's say tg, 6d divided by v, no? So now due to this retardation and acceleration, then t1, t2, t3 time addition surely greater than tg. Continue. Now here time loss t1 plus t2 plus t3 minus tg. That is our time loss. t1, t2, t3 minus tg. Then 2d over u plus v, 2d over u, 6d over u plus v, no? U plus v minus 6d over v. 6d over v. Now when you simplify this, definitely you get the answer. Continue. Take your time, do alone. Then here 8d over u plus v, 2d over u, 6d over v. Then take 2d outside. For uv, same time get common denominator, u plus v into v, 3 into u plus v into u. U plus v, uv. Then 2d, 4uv, 5uv, 2uv plus v square minus 3u squared divided by u plus v, uv. Then we can factorize it. V minus u, v plus 3u. U plus v, uv. That is it. That is 2008 Taylor question. Okay, now let's move to special questions again. Take your tutorial, page 43, question number 43. First read and start. Question number 43. Question number 43. First read and start. Okay, you better to mark it as special question, somewhat special. No? Question number 43, better to mark it. Okay, first I'll show you how to do it. A car starts from rest with uniform acceleration f, it comes to rest under uniform retardation. The maximum speed acquires u. Find the minimum time taken by the car to travel distance a when we have two cases. So initially it has to retardate, it has to accelerate then retardate, no? So if we have some displacement, some large distance, then we need to go acceleration, then uniform velocity, then retardation, like that. But for some small displacements, accelerate, then we can just retardate, no? First we have to accelerate, then we have to retardate for small displacements. But for large displacement, we have to accelerate, moves with uniform velocity, then retardation. Okay? Then here, let's take this, we have to reach velocity u, no? we have to reach velocity u. Then question number 43. So let's do this way. Here time velocity, here acceleration, reach velocity u, f. Then here it asking find the minimum time taken by travel distance a. We have two cases, a equal u squared over f and a greater than u squared over f. We have two cases. Now first you think this way, here it accelerate, reach maximum velocity, then just retard it. You think this case, huh? So here time, acceleration, same velocity, no? Then time, same, t, t. Then displacement a. Then tan alpha equal f equal u over t, then t equal u over f. Then here a displacement, area of this triangle, half into 2t into u, no? Then tu, t mean u over f into u, so we get u squared divided by f, no? So in that case, we need u squared over f displacement. Accelerate, reach maximum velocity, then retardation, reach u squared over f displacement. Okay. So if the given displacement greater than this one, let's say a1 is this, a1. So here we have two cases. If a greater than a1, so now we need to move with acceleration, then thereafter we have to reach velocity u and maintain that velocity, then finally we have to retard it for a greater than a1 displacement. So it has to maintain u. Here time t, we know that time, same time here, no? Same time here t. So we have to maintain u displacement. Then finally full displacement given by this shaded region. Then if a less than a1, so here consider this displacement. Now here this is a1, here this is a1. So for this case it can accelerate and reach maximum velocity, then it can just retard it and come to this position to rest. So if that displacement greater than a1, it can accelerate, then uniform velocity, finally it has to retard it. If that displacement less than a1, then it accelerate and then retard it. No? In that case, it can't reach u. So for a less than a1, now the VT graph is this. Here time, here velocity, maximum acceleration, it can't reach velocity u, now it is just say v1 and then retarded, but displacement you can find, no? Here acceleration f, here time t1, time t2. Okay, now identify when a value greater than u squared over f, it has to maintain uniform velocity. If a value less than u squared over f, then it can accelerate, then it can retard it, but it can't reach velocity u, no? Okay, now these two cases you find different times. Okay, continue now. You think that you know a and f, then here take here capital T, then here tan alpha f, u over t, then t here u over f, then here full displacement a, half into u into here total time 2t plus capital T plus again capital T. A over u equals simple T u of f capital T. Then capital T a over u minus u of f. Therefore, total time for this case, 2t plus capital T, 2 u of f, u of a over u minus u of f. Now, u of f plus a over u. Here that case, time. U of f plus a over u is time. Here first case. Second case, take alpha here displacement A. Then T1 here same T1 time same. So second case tan alpha V1 over T1 is F, then full displacement A. Then you write two relations. Second case tan alpha F V1 over A, V1 over T1, T1 V1 over F, or V1 equal FT1. Then total displacement A half into 2T1, half into 2T1 into V1, T1 V1 FT1, T1 squared. Then T1 equal A of F root. Now here for this case total time 2T1, 2A divided by F root. Here this is the total time now. Okay. Identify that question. That is very special relation. So otherwise if you don't have any experience, you can't do this one. Okay. That is question number 43. Then you try question number 44. Try question number 44, same type. Okay, question number 44. Question number 44, same type question. Same type question. So here maximum speed of a newly manufactured car is V on test drive is driven on a rectilinear path with acceleration F1, retardation F2, no? If the car acquires its maximum speed in this test drive, we have to sketch VT graph. Then minimum length of the path need to find, no? So it need to accelerate and reach maximum velocity V, then retardation, same type. Then you do this, say, here time velocity, acceleration F1, reach velocity V, retardation F2. Here time T1, here time T2, say alpha beta. Then tan alpha F1 V over T1, T1 V over F1. Then tan beta F2 V over T2, then T2 time V over F2. Then we need displacement here, minimum length, let's say DL, DM, minimum displacement. dm equal, here this area, half into v into t1 plus t2. Here it is. Now you simplify this one. 1 over 2v, t1, v of f1, v of f2. Then v squared f1 plus f2 over 2 f1 f2. Get common denominator and simplify. That is the displacement required to minimum length of the path. Now find the least time taken for the journey when the length is 2v squared f1 plus f2 over 9 f1 f2. Now take here dm. Now here 2v squared over 2v f1 plus f2 over 9 f1 f2. So here v squared over 2 f1 f2. Here 2 over 9. No? Then this is surely less than dm. No? Then v squared there, f1 f2 there, sum f1 f2 product there. Then here denominator 2. No? Now here we need divide by 9. Then here half. Here 2 divided by 9. Then 2 divided by 9 surely less than half. No? Therefore here this displacement less than dm, maximum displacement. Therefore corresponding graph will be acceleration reach maximum velocity, then retardation. Now take alpha beta, f1 f2, it can't reach maximum velocity, you have to take another velocity v1. Okay. Then here displacement 2v squared f1 f2, length of the path given. No? Then here take time t1, here take time t2, here you take this one d, I'll take this one d, yeah? Displacement d. So here displacement d equal half into t1 plus t2, t1 plus t2 times v1. Then tan alpha f1 v1 over t1, then v1 ft1 then v2 similar tan beta f1 f2 v1 over t2 ft2, then t1 time v1 over f1 1 over 2 v1 over f1 v1 over f2 v1, take here 1. Now you simplify that, just simplify. Then d equal 1 over 2 f1 plus f2 f1 f2 v1 squared. Okay. Now you simplify very carefully. Yeah? Simplify very carefully. Then here v1 equal 2d f1 f2 f1 plus f2 root. Here v1 time. Then total time, here total time t1 plus t2, then t1 equal v1 over f1 plus v2 over f2 v1 over f2, then take v1 outside, f1 plus f2 over f1 f2. Now v non, substitute it. Okay, then further see, so we have to substitute d, here. Then total time, say capital T, v1 mean 2d f1 f2 f1 plus f2 root here f1 plus f2, f1 f2. Now simplify. Here 2d f1 plus f2 over f1 f2 root. Here the time for that case. So before again we have to substitute d value 2v squared f1 plus f2 over 9f1 f2. f1 plus f2 f1 f2 all thing root. 2d value substitute. Now you simplify. Here 2 square take outside, v square take v outside, f1 f2 square take f1 plus f2 outside, and 9 root 3 f1 f2 square root f1 f2. Here the time now. 2v f1 plus f2 over 3 f1 f2. Check simplification. Huh? Then case number 2. Case number 2, now displacement larger than the minimum displacement. Then case 2. Here 2v squared f1 plus f2 over 3 f1 f2. Here less than d, greater than f dm. Therefore, such case, here time velocity, so maximum acceleration, then reach maximum velocity, that is given v, then we have to maintain it, then we have to retard it. No? Then here f1, f2, alpha, beta, take capital T, here T1, T2. Tan alpha f1, v over T1, then T1 equal v over f1. Tan beta f2, v over T2, then T2 time v over f2. Then f1, f2 given, v given. Now displacement d, take this one d, you think d is given. Now d equal half into trapezium area, v into T1 plus T2 plus capital T plus T. 2d over v minus T1 plus T2 equal to capital T. d over v, T1 plus T2 over 2, then total time T1 plus T2 plus capital T. Now simplify. 1 over 2 T1 plus T2 d divided by v. T1 v of f1 v of f2 d of v. So d value already given, then you get final answer. Simplify and get final answer. So here according to the displacement, we have to think the relevant graph, no? We have to think the relevant graph. Complete. Okay. Then you go to question number 67. That is another special case. Huh? Complete this one and go to question number 67. You can simplify a little further. 1 over 2 v over 2, f1 plus f2 over f1 f2, d over v, d is this, no? d over v, 2 v f1 plus f2 over 3 F1 F2, then 6 F1 F2 common, then V F1 plus F2 common, here 4 3 7, 3 into 2 6, F1 F2, V common, F1 plus F2 common, here 3 plus 4 7. Okay, question number 67. Question number 67. That also a special question. First you get this one. First you see this. A motor car travels this straight road. Here time velocity. First check this one all. I'll give you another question. First check this one. A motor car A travels on a straight road passing a point O with uniform retardation F and speed 2u. Here retardation F and decrease to u. It decreases to u. Then it maintains the velocity. Here car A. Here point A. Here car A at O, point O. So at the moment uniform speed begins, here at the moment uniform speed begins, let's take time t1. Another car B start from O. Here now A somewhere here, no? Now B gonna start. Here T equals T1. Now B gonna start. So uniform acceleration, that is given F, and reach velocity lambda u. Here lambda u. Lambda given greater than 1. Now here car B. Here car B. First check this one all. Now we have to get an inequality. B cannot overtake A. B cannot overtake A. So here there's special thing. Here there's last possibility happened here. Last possibility happened here. Now you think now A somewhere here, B going to start now. So from here to here, this velocity of B is less than the velocity of A, no? Velocity of B less than velocity of A. Therefore, definitely for this region, take time t2. Then for this region, B cannot overtake A. Surely B cannot overtake A. But from here to here, B velocity greater than A velocity. Now for this region, it has possibility. So here possibility to pass A. B has possibility to pass A. But here last possible time. Here this is last possible time. Last possible time. So here last possible time, thereafter you can't again pass, no? So you have to think about last possible time here. Otherwise we can't say. So now we need to think B cannot pass A, then displacement of B must be less than displacement of A, no? So you take this last possible time, then you consider displacement of B and consider displacement of A, then displacement of B must be less than displacement of B at that point. Don't consider full graph, you have to stop here. That is last possible time. That is the important thing. Here the important thing. Okay, now continue. Here take time t2, here also time t2, t1, t1, t2, t2. So here t1, yes, t1, 2u minus u, no? U over same time, no? t1, t1, t2, t2. Same acceleration, retardation, therefore time same. Tan alpha if 2u minus u divided by t1, t1 u over f, here this alpha, tan alpha f lambda u minus u divided by t2, here lambda u minus u divided by t2, then we know t2 value, lambda u minus u lambda minus 1 over f, t1 t2 time, t1 t2 time. Then not to pass B, displacement of B less than displacement of A. So identify this last possible time, otherwise we can't get solution. Let simple t equal 2t1 plus 2t2 position, 2t1 plus 2t2 position. Then displacement of B less than displacement of A. Here not to pass. Displacement of B less than displacement of A. This is also a very rare question. So we have to identify last possible time to pass. Now continue. Displacement of B here, triangle plus trapezium, half into T1 plus T2 into lambda u, trapezium half into T2 lambda u plus u. Continue. Displacement of A. Then displacement of A, write this area. Then first trapezium half into T1 into 2u plus u. Here 2u plus u, and here this rectangle plus u into T1 plus 2T2. Here it is. Okay. Now we have inequality now. We have to solve that one. That's it. Now solve this inequality. We know T1, T2. Before that, you first remove u value. First remove u. Then multiply by 2. Lambda T1 plus T2. T2 lambda plus 1. T1, 3T1, 2T1, 2T2. Now you get same type terms together. Lambda T1 minus 3T1 minus 2, 5. T1, then lambda T2, lambda 2 lambda T2 plus 1 minus 42. Now lambda minus 5, T1 u of f, 2 lambda minus 3 T2 u lambda minus 1 over f less than 0. Now we have lambda inequality. Lambda minus 5 plus here 2 lambda squared minus 2 lambda, 3 lambda minus 5 lambda plus 3 less than 0. Now this is lambda inequality. Now here 2 lambda square minus 4 lambda minus 2 less than 0. Then here it is. Now further we can simplify. Here lambda square minus 2 lambda less than 2. Now get complete square method. Minus 1. No? Then lambda minus 1 square minus 1 square less than 0. Lambda minus 1 square less than 2. Now here this inequality, usually we can't get square roots, but here lambda given greater than 1, lambda greater than 1. Therefore you can take square root for this. Okay. Then lambda minus 1, don't put plus or minus. Okay. Usually for algebra we have to put plus or minus. And again for inequality we can't take square root. But for this case we know lambda greater than 1 value, then this is positive, surely positive. Then no need to put plus or minus, and again both sides positive, then we can get square root. Then lambda less than 1 plus root 2. That's how we do that one. That was a very special question. Huh? You have to practice these questions again and again because these are very special cases. So you have to practice again and again. Complete. Further you have similar type question number 74. Question number 74. Okay. Question number 74. Similar type question we have to analyze similar way. Okay. A motor car A traveling with uniform retardation, take F, has velocity 2u. When passing the point P. After time t1, its velocity decreases to u and continue to travel with uniform velocity u. At the instant when the car A begins to travel with uniform speed, another car begins its motion from P in the same direction as A. B moves with uniform acceleration F and finds its velocity after time t2 is ku. Then B travels with uniform retardation F. Okay, we have to show inequality. Here time velocity 2u, here u, here car A, here start at this point ku, then retardation, here B. Now here last possible time. Here t1 time given, here acceleration F, retardation F. Here time t2. T2. Okay, then I'll take time here T3, here this time T3. Here in this section T1 already there, T2 already there, but we have to remove T3 now. Then you first find T3. U divide by here T2 minus T3. U divide by, before that Ku divide by T2. Ku divide by T2 equal Ku minus U. U divide by T3 na. Then by this you find T3. T3 equal K minus 1 T2 divide by K. Divide by K, no? T3 equal K minus 1 T2 divide by K. Okay. So in this answer, we have T1, T2 mentioned in there, no? Then no need to worry about that one. So we need to only find T3 time. Then when you consider this triangle, Ku divided by T2 equal Ku minus U divided by T3. By that one find T3 value. T3 value. Then acceleration F, retardation F, then same T3 value here. Same T3 value. Same T3 value. Then here also we have to find B not to overtake A. No? B not to overtake take A. Then displacement of B less than or equal displacement of A. For equality also that not pass, it just reach, just meet. Equal case just meet, not overtake, just meet. Okay, then here you have to consider last possibility. Here last possibility. Possible time. Okay, then displacement of B. Here consider this area. Then first get triangle half into T2 into Ku. Here this triangle plus trapezium half into T3 Ku plus U. Less than or equal displacement of A. Here this trapezium half into T1 into U plus 2U plus then this rectangle U into T2 plus T3. Now we know everything. Now we need to simplify only. Okay? Now just simplify. Just simplify now. Now first you cancel U term, then multiply by 2, KT2, K plus 1 T3, T3, K minus 1, T2 over K, here T1, 3 T1, here 2 T2 plus 2 T3, K minus 1, T2 over K. Here is. Now we have to simplify this. One. Multiply by K, K square T2, K square minus 1 T2, 3K T1, 2K T2, 2K minus 1 T2. Okay, no? Here K square T2, K square minus 1 T2, 3k t1, 2k t2, 2k minus 1 t2. Now get t2 terms together. 2k square, yeah, k square plus k square minus 1 and minus 2k minus 2k plus 2 t2. Again you take t1 terms together. Better get other side. 3k t1. We have only one t1 term, no? Simplify. 2k squared minus 4k plus 1 3k t1 over t2. Divide by t2 now. Now we have reached 3t1 over t2. Again you divide by k. Now you divide by k now. Okay. Then 2k square minus 4k plus 1 over k. 3t1 over t2. Now both sides at 3. At 3. 2k square minus 4k plus 1 over k plus 3. 3 plus 3t1 over t2. Now separate denominator. 2k minus 4 1 over k plus 3 3 plus 3t1 over t2 2k plus 1 over k minus 1. We missed something. We get this, okay? This is not there. Let's see what has happened. K square minus 1. Here t3. Ku minus u divided by t3. Ku divided by t2. Then t3 k minus 1 t2 over k. That is okay. I think our one is correct. Okay. First, continue now. Continue. Check answer. අපේ මේකේ මිස් එකක් මිස් යන්නේ නැහැ නේ මෙතන මේක 1 අයින් කළා මෙතන 4 කරගමු. මේ ආන්සර් එක ගන්න. Okay. That also very special question, but the previous question also same. Read question number 76. Read question number 76. That also another special one. That is given in terms of ij vector format. Question number 76. First read it well. Question number 76. Okay, question number 76. AB two places. I is the unit vector in the direction AB, J is the unit vector perpendicular to AB. Okay, vector form. So we have I and J components. So here this is special again. 76. Check this. here AB, here unit vector I perpendicular to that unit vector J. Rocket R1 start with constant acceleration. Okay, here rocket R1, its acceleration F I plus J. F I plus J mean horizontally F, vertically F. Here acceleration, rocket F. It has second rocket at t equals t naught with acceleration F, 2F minus I plus J. Then here opposite direction 2F, here 2F. Here the accelerations. Vertical acceleration F2F, horizontal acceleration F minus 2F. Then R1 start at T0. Consider initial velocities are 0. Consider initial velocities are 0. Then second rocket after time t naught, no? Okay. Now here we have horizontal one. Horizontal and vertical components. We have horizontal and vertical component. So let's sketch this way. Here horizontal component, we have positive negative case. Therefore, positive case consider first quadrant, negative case fourth quadrant. I'm going to consider here positive directions. Then rocket A, rocket R1, horizontally F. Then here alpha is acceleration F, rocket R1. Then rocket R2, opposite direction 2F, start at T naught, here T naught. Then opposite direction we can sketch this way, beta. Here 2F, here R2. That is horizontal. Then vertical one, here time axis, velocity axis, vertical. Then initial velocity 0, acceleration F. Here same angle, here R1. R2 rocket start at T naught, here T naught, acceleration 2F. Same direction, okay? Angle beta, here beta same. So when they collide together, it moves this way. When they collide together, both case vertical displacements are same, no? When they collide together, both case vertical displacement, here vertical displacement are same. Because when they collide, they are at same point, no? Therefore here you consider at the collision here, then corresponding time, here T1, here T naught. We have to project the time, here T1 time. Then here vertical motion. So vertical motion, here this displacement, you equate to displacement of this area, triangle areas. Then here F, 2F. So mark here V1, mark here V2, find V1, V2, and here this triangle area, and here this triangle area must be same. Now start. So anyway, you identify IJ format given, I mean horizontal, J mean vertical. I mean horizontal, J mean vertical. You consider horizontal motions each case and vertical motion each case, separate diagrams. Okay? Sketch it and continue. Continue. Yeah, I'll write here tan alpha F equal V1 over T naught plus T1. Then tan beta value 2F This is V2, no? V1 over T1. V1 2F T1. 2F T1. Okay, when they collide, half into T1 into V2, V1 equal half into T0 plus T1, T0 plus T1 into V1, V2. Then T1, V1, 2F T1, T0 plus T1, V2, T0 plus T1, F, 2 T1 square, T0 plus T1 square. Now you have to get square root both sides. T0 plus T1 equal root 2 T1. No need to put plus or minus because time positive always. Then we have to subject T1. Then take T1, root 2 minus 1, T0, T1, T0 over root 2 minus 1, multiply by conjugate now. Root 2 plus 1. Then AB displacement given by this area. AB displacement. Horizontal displacement you add. You add horizontal displacements to find AB. Consider first practical case. Here, two rockets launch, then it move face-to-face motion, but vertically same direction, horizontally face-to-face. Therefore, vertically, their displacements must be same. That's why we took here this area, and here this area same. No? Then here, area same mean vertical height same. Then they meet at that point. Then horizontally face-to-face. Therefore, AB distance given by here this full area, AB distance. Then you find here this velocity V2, V3 minus V4 tan alpha F V3 over T0 plus T1, T0 plus T1 F, in tan beta V4, this is 2F now, here V4 over T1, 2F T1. Now AB displacement here, full area. Then AB displacement you can find. Half into V3 times T1 plus T0 plus half into V4 times T1. V3 F T0 plus T1 half V4 2F T1 F over 2 common T0 plus T1 square 2 T1 squared. Then T0 plus T1, we got that no, T0 plus T1 root 2 T1. F T1 squared. Now need to simplify up to that, but anyway, you identify how it is happen. Okay. Then The specialty ij format velocities, acceleration given. Ij format velocities and accelerations are given. Okay, start 2020 allocation. 2020. Here P, Q, R, A kilometers, 140 kilometers, time velocity. Here I'll take positive direction. Train is start from P and moves towards Q, constant acceleration F. Here V, kilometers per hour, T hours, here for half hour. Half hour, it reached velocity V. And 3 hours it maintained that velocity. Then it moves it constant retardation F and comes to rest at Q. Okay, then acceleration F, retardation F, angle alpha, here T equal half. Then 140 kilometers total displacement. 3 railway station, PQ 140. Initially train A, acceleration F, half hours, and maintain velocity 3 hours, and retardation, then total 4 hours. At time 1h, here somewhere here, 1h, Q 2F. Here 3 hour, here 1, here alpha 2F. Here take angle beta. And retardation F, alpha F. Then acceleration for capital T time. Here 1, then here this gap will be capital T. T. Then here total time 4 hours. 4 hours. Here 1 hour, that means here traveling time 3 hours. Here T no. Then for this part 3 minus capital T. Retardation time 3 minus capital T. Then is displacement simple A. Displacement simple A here. Sketch VD graph. Hence, otherwise show that F equal 80. We have to show F equals 80. Now you write general relations. Just write relations. Then here tan alpha equal F V over half equal to V, first relation. Then total displacement 140 equal area of the trapezium half into V into here 4 plus here constant velocity 3 hour 7 20 V equal 40. Therefore, by 1 F equal 2 times 40 80 kilometers per square hours 80. Then find the value of T and A. Then here 3 hour, no? 3 hour tan beta equal to 2F. Here take velocity minus V1 over T. Then again tan alpha F V1 over 3 minus T. Here time gap 3, no? 3 minus T. Now we can divide them. Then you can easily obtain V1 value. 1 divided by 2. 2 equal V1 cancel 3 minus T over T. 2T 3 minus T equal 1 hour. T equal 1 hour. Then here displacement will be A. Therefore, A value half into V1 into here time period 3 hours. V1 2FT times 3. F value 80, T value 1, 240 kilometers. 240 kilometers. Try 2022. 2022. A car P begins its journey from rest from point on straight horizontal road, travels with constant acceleration 2F up to point A or A meters. A car P, acceleration 2F, point A, displacement A meters. It maintains velocity. Thereafter it maintains velocity, take V. Through the remaining journey, then continuously velocity V. Here time, velocity, acceleration, reach velocity V. It maintain here car P. Here displacement A meters. We have to take time T1. At the instant when the car P reaches the point A, another car Q begins its journey along the same road same direction from rest. So when P comes to here, Q start. Now Q is here. Then here the point, question. Moves with constant acceleration F. Now acceleration F, you show here angle alpha, here angle beta, here acceleration 2F, no? Here acceleration F. So, some less angle, here PQ. Okay. Now show that the time taken Q to the instant where the velocity P and Q are equal. Then here velocity equal position. Take time T2. Take time T2. Velocity equal position. Now just write relations. First tan alpha mean 2F equal V over T1. V over T1. Then here V equal 2F T1. V equal 2F T1. Then displacement A, here this area A. This area A. Half into T1 into V. Then V substitute 2A T1, 2F T1 squared. Then by this T1 A divided by F root. T1 A divided by F root. T1 value A divided by F root. Okay. Then similarly we can find now V value. Then 2F T1 V. T1 A of F root. V equal to AF. Then T2 time tan beta. Tan beta F. V over T2. V value 2 AF root to A divided by F root. Show that the time taken by Q, here time taken by Q is this, 2A divided by F. Now further given that A 50 F2, A 50 F2, F equal to, then T1 time 50 over 2 root 5, T1 5, T2 10, V 2 F T1 20 meters per second, here 5 seconds, 10 seconds. V20. Okay. Then 2F T1, 2 times 4, T1 5, 20. Now they meet at point on B. Then here meet in position. මේක මේ මට මතක විදිහට මේ question එකේ පොඩි trouble එකක් තිබුණා මේ ඔක OBද ABද කියන එක මට මතකෙද මේ කරෙක්ට් කරලා දුන්නා. ඒක A level question එකේම අවුලක් තිබුණා. කියන්නේ A level question එකේ මේ අහන එක ආවේ නැහැ. ඒ අවුරුද්දේ මම මේක හදලා වගේ මතක විදිහට දුන්නේ මෙතන දෙද්දී. question එකේ ප්‍රශ්නයක් තිබුණා. Okay. Then when they meet, their displacement same. When they meet, here take displacement A 50 no? 50 plus T2 into V. A plus T2 into V equal T2 plus take time capital T equal half into T2 plus T V1. Here take time velocity V1. Then simplify that. When they meet, their displacement must be same, no? When they meet, their displacement must be same. Here, displacement of P and displacement of Q are same. Now you can simplify this. Okay. Tan beta F V1 over T2 plus T. F equal to T2 equal 10. V1 2 times 10 plus T. Okay, now you substitute everything here. Here 50, T2 10, capital T, V equal 20, 1 over 2, capital T, T2 10, V1 2 times 10 plus T. Now just simplify. 50, 200, 20T, T squared, 20T plus 100 binomial. 20T, here T equal 150. T equals 150. 150 root. Five root 6. 5 root 6 second. Then OB distance means here one area of triangle, and OB half into V1 into T2 plus capital T. Here area of the triangle. No? Okay, now then simplify. Here this area OB. V1 to 10 plus T, 10 plus capital T. Five root 6 squared. Take 5 outside, 25. 2 plus root 6 squared, expand. 4, 6, 4 root 6, 10, 4 root 6, take 2 outside, 50, 5 plus root 6, 5 plus 2 root 6. Meters. ඒ level question එකේ ඕකේ AB distance කියලා දීලා තිබුණේ. AB නෙමෙයි OB වෙන්න ඕනේ. මේක මම මෙතන හදලා තියෙන්නේ. For now, we can stop linear motion for now, but we have to discuss something with collisions and we have to discuss something with relative velocity, and again we have to discuss something with Newton's laws, system of Pauli corrections. Okay, later we will discuss them. Okay, for now we can complete linear motion.